In this nutshell, I look at the registers used to control and use the USART. I look at the ATmega256 USART features. I give a block diagram of the registers and how they interconnect to each other. Then I explain the registers, the data register, control and status registers, and the baud rate register. Remember, if you find this nutshell useful, please like and subscribe. The USART on the ATmega2560 is capable of full duplex operation. It can work in both synchronous and asynchronous operation. It has an internal baud rate generator. It supports 5, 6, 7, 8 or 9 data bits. You can configure it for 1 or 2 stop bits. It has odd or even parity generation and parity check. And then it also has multi-processor communication. This is unique to the device, and it allows the USART to connect to multiple devices by using an address frame. Looking at the internal registers and the USART structure, we can see it's broken into 3 parts: the clock generator, the transmitter, and the receiver. So the clock generator has a baud rate generator, which is controlled by the UBRRn registers. And then it has pin control, so we can actually use this for synchronous or asynchronous operation. And it runs in 4 modes: asynchronous normal or double speed, synchronous master or slave. The transmitter has a write buffer, UDRn, a serial transmit shift register, and a parity generator. When we are writing data out to the serial port, first we check the transmit buffer empty flag here. If it's empty, we write data into this register. That is then put into the transmit shift register. If parity is set, then the parity generator will add a parity bit, and then the data will be sent out the external pin of the microcontroller. The receiver has a parity checker, a receive shift register, and a double buffered receive register. The serial data will come in on the serial port, and it can be checked for parity if parity is set. The data is put into the receive shift register. When that data has been complete, it will be loaded into the UDRn register here. When that register has received data, the receive buffer register full flag will be set. This is double buffered, so we can have 2 bytes of data waiting to be read. And finally, the USART has 3 control registers: UCSRnA, B, and C. Looking at the registers used by the USART, we have 3 control and status registers, 2 baud rate registers, and a data register. Now there are 4 USARTs in the ATmega2560, so to identify each USART we use the number N in the register names. For instance, if we're using USART 0, then the registers inside it will have the 0 at the end. If we're using USART 1, then the registers will have 1 at the end. The first register we're looking at is the data register. Now this serves for both transmit and receive functions, and we can access the receive or transmitter depending on the operation. If we read the register, UDR register, we will access the receive buffer. If we write to the UDR register, we will access the transmit buffer. So for example, if I read it using receive data equals UDR1, then we look at the receive buffer. If I write to that register using UDR1 equal TX data, then that will write to the transmit buffer. If I do this, UDR1 equal UDR1, it will read the received data and transmit it out the transmitter. So if you're transmitting data, check that the UDRe is empty and then write to the UDR register. If you are receiving data, check to see the receive complete flag has been set, then you can read the UDRn register. The USART control and status register A shows the state of the USART. So bit 7 indicates that the USART has received data. It is set when the received buffer has received data, and it's emptied when we have read the received buffer. Remember, this is double buffered, so that might have 2 bytes inside it. The transmit complete shows that both the UDR transmit register and the transmit shift register are empty. This shows that all data has been sent, and we normally use this before powering off the USART transmitter. The USART data register empty. It's set when the UDR transmit register is empty, cleared when new data is loaded into it. So you want to check this before writing to the UDRn transmit register. A framing error is set when the USART detects a missing stop bit. That's normally because of an incorrect baud rate, but it could be noise as well. This is cleared when the received buffer is read. Data overrun error is set when new data arrives before the previous data has been read, and this will cause data loss. It's cleared when the received buffer is read. Bit 2, parity error, set when a parity error occurred on the received byte, cleared when the received buffer is read. Finally, bit 1 is used to set double speed for the transfer rate when using asynchronous communication. And bit 0 is for multi-processor communication mode. This is not a common action for a USART, but it allows the USART to connect to multiple processors or devices on the USART line. This requires a frame that includes address information as well as a data frame. The USART control and status register B is used to enable the interrupts, to power on and off the receiver and transmitter, to select the character size, and is used for the bit 8 when transmitting 9-bit frames. So looking at bit 7, the receive complete interrupt enable. When this is enabled, an interrupt will occur when new data arrives into the receive buffer register. Bit 6, transmit complete interrupt. Enabling this will generate an interrupt when both the transmit buffer and the transmit shift register are empty. Now we often use this when powering down a transmitter. The bit 5, the data register empty. Enabling this bit will trigger an interrupt when the transmit buffer is empty. Bit 4, this is used to power on and off the USART receiver. Bit 3 will power on or off the USART transmitter. Bit 2 is used with bits 1 and 0 in the USART control and status register C, and that's used to select the data length. And if you are sending 9-bit frames, then bit 1 and bit 0 are used for the 8th bit. And note, if you are enabling the interrupts, you must also enable the global interrupts. The USART control and status register C is used to configure the operation of the USART. Looking at bit 7 and bit 6, this is used to select how the USART operates. It can either be in asynchronous mode, synchronous mode, or as a master SPI. Bit 5 and 4 are used to select parity. We can have no parity, even parity, or odd parity. Bit 3 is for the stop bit select. We can have either one stop bit or two stop bits. Looking at the character size, bits 2 and 1. This is combined with the UCSRn2 in the USART control and status B register. And we can select 5, 6, 7, 8 or 9 bits in the frame. And finally, we can select the clock polarity if we are using synchronous mode, and we can select rising or falling clock edges. The baud rate registers UBRRnH and L are used to select the baud rate that the transmitter and receiver will operate. Now we can find the values for these registers using either the tables from the datasheet or by applying the formula. And note, if the value is less than 255, we can store the value directly into the lower register. So looking here at the table, if we were going to transmit 2400, we have an 8 meg clock. We can simply use the table and load 207 into UBRRL. Alternatively, we could use a formula here to calculate the value for the registers. The frequency of the oscillator over 16 baud minus 1. I've performed the calculation here to get the same value here as in the table. Now note, if you're loading a value greater than 255, you need to break the value into 2 hex sections and then load the hex number individually into the registers. So therefore 452 decimal will load the high register byte with 01 and the low register byte with C2.